this question is from GATE 2016 Mechanical Engineering paper set to question number 11. A machine element XY fixed at X is subjected to an axial load P, transverse load F and a twisting moment T at its free end Y. The most critical point from the strength point of view is option A point on the circumference at location Y, option B, a point at the center at location Y, option C, a point on the circumference at location X, or option D, a point at the center at location X. Let's look at the system, what all loads are being applied and what will be the effect of all these loads. Now, number one load that we can see is the axial load P. This will lead to axial stress sigma. Let that be sigma A. Sigma A will be uniform throughout this cross section and the distribution will look something like this throughout the depth of the cross section, depth and width of the circular cross section. Now let the second load be this transverse load F. So we have a transverse load F. This will subject the machine element XY to bending moment throughout. This bending moment will be maximum at fixed end. Fixed end is point X. Also, distribution of this bending moment is something like this. Depending upon the nature of bending moment, this can be positive and negative like this. But a part of the section will be subjected to compressive stress and a part will be subjected to tensile stress. In this case, the cross section is circular and hence this will be symmetric. Throughout half of the depth, it will be compressive stresses and throughout the other half will be tensile stresses. So we can see that at the circumference, the bending stress value is maximum. This is obtained by using the pure bending equation M by I equal to sigma by Y, and this sigma is nothing but the bending stress. Let it be sigma B. Now if we rearrange, we can see that sigma B is equal to My by I. Y is the distance from centroidal axis, distance of the fiber that we are calculating stress at from the centroidal axis. And here the maximum distance is of the extreme fiber that is at circumference, and hence bending stress will be maximum at circumference. For the effect of transverse load, a point anywhere on the circumference at fixed end X will be a critical point. Now let's look at the third load, that is the twisting moment T. We have third load which is twisting moment. For this we will use the pure torsion equation. We have T by J, polar moment of inertia, J, T is the torque, is equal to shear stress due to torsions, that is torsional shear stress, divided by R. R is nothing but the radial distance from center of the shaft. Here also we can see that shear stress is equal to TR by J. Hence shear stress is directly proportional to the radial distance from center. So from point of view of torsion also, the circumferential point will be the critical point. Thus, by superposition effect of all the three loads, we can say that any point on the circumference at X will be a critical point. Let's mark the correct option. It is option C. A point on the circumference at location X will be the most critical point from the strength point of view. Because it is subjected to the maximum stress, it will be the most critical point. For more information on this, you can refer to the NPTEL video Analysis of Stress 1 from the course lecture series on Strength of Materials by Professor S.K. Bhattacharya. He is from Department of Civil Engineering, IIT Kharagpur. I hope this explanation will help you clear your doubt. Thank you.